Hello again. So this is the first video to go along with section 1.3, which is on intercepts and graphs. So the first thing we're going to do is we're going to define our input and our output, because even though we've been using that in the previous videos, we never really gave it formal definitions. So let's talk about input versus output. Okay, our input is usually what do we need to know first? Okay, so in general, there's something that you're going to be plugging in. Okay, input is typically plugged in to an equation. Okay, so it's usually within the equation. Input is usually plotted on the horizontal axis. When we're in our comfort zone, the input is usually X, but input and output do not have to stay X and Y. They can change variables, because in real life, how often are you going to see X and Y? The input is also called the independent variable. And there's an easy way to remember that. In and in, input is independent. And that often means that this is going to be something that's going to happen no matter what. Okay, you don't really have that much control over it, or it's your choice. Okay, what do you want to see happen? What do you want to test out? Okay, so it's independent in that it doesn't depend on anything else. Okay, so it can be totally up to you, or it's going to be something that is going to go on and happen no matter what. Okay, so now let's take all of these things and talk about them in terms of output. Okay, so the question you ask yourself is, what do I get as a result? Okay, so what is the answer? What am I trying to solve for? Okay, the output variable is usually alone on one side. Okay, so it's already solved for. Okay, it's the thing that you're going to be getting as an answer. It's plotted on the vertical axis, and it's the dependent variable. The reason that output is dependent is because the output that you get depends on the input that you plugged in. So the output depends on the input. Okay, that's always going to be your relationship. When we're talking about ordered pairs, we all know that an ordered pair would typically go X comma Y, but now that we're talking input and output, it's not always X and Y. So we're talking input comma output. Okay, it's very important for you to ask yourself about input and output at the start of any type of problem. Okay, so whether it's a word problem or it's function notation or anything that you might be talking about input versus output, you want to start with that question. Okay, what is my input? What is my output? In previous videos, we already talked about what a complete graph is. A complete graph is when you see all the important features. Okay, so we want to make sure that all those key features that we've been talking about are visible when we make a graph. And in this chapter, we're going to be seeing how we use technology for that. I don't think it'll be this video. I think it's going to be the second part of this video. So now I want to get into kind of a connection of input and output. I want to talk about the x-intercept versus the y-intercept. Now, our comfort zone is x and y. And when we start using our graphing calculator, if that's the method that you choose to use, the technology you choose to use, your calculator really only understands things in x and y. So that's why we tend to go back there. But it's important that you can break out of this x and y. So the x-intercepts can also be thought of as the horizontal intercept, because it's where you're crossing the horizontal axis. And the y-intercepts can also be thought of as the vertical intercept, because that's where you're crossing the vertical axis. We already talked an awful lot about the y-intercept, because we talked about all of the three different types of functions, linear, exponential, and quadratic, and how to find the y-intercept, okay, where the y-intercept has a role in each of those functions. We didn't really give it any formal definitions though, so that's what we're doing here. I like to do these definitions threefold. I like to give you a graphical definition, a numeric or a table definition, and a symbolic definition. So this way, no matter what, you know how to identify or find the x and y intercept. So we're going to do graphically first, because we've done that already in previous videos, and it tends to be the most straightforward. So the x-intercept is the point where the graph crosses the x-axis. And then that means for the y-intercept, it is the point where the graph crosses the y-axis. So if I were to make a little sketch of a linear over here, okay, I can identify that this is my x-intercept. That's the point where the line is crossing the x-axis. And this is my y-intercept, okay? Now, let's think about what that means, because this is going to lead us into our table definition. If I'm on the x-axis, I did not move in the vertical direction at all, okay? I just stayed horizontal, and we know that the x movement is always first. So I moved in the x direction, but then I didn't move in the y direction. So that tells me that my ordered pair is going to be some x, comma 0. I moved in the x direction, but I did not move in the y direction. What about for my y-intercept? If I'm sitting on the y-axis, I did not move in the x direction, okay, and horizontal is always plotted first. So I didn't move horizontally, so that's going to be a 0, and then I moved whatever distance I moved in the y. So you're always going to see a 0 for your output when you're talking about the x-intercept or the horizontal intercept. You're always going to have a 0 for input when you're talking about the vertical intercept or the y-intercept. I said this leads us directly into our next definition, okay, the table part of this definition, because if you were to look at a table and you saw some number with 0 and then 0 and some number, you should be able to identify based off of this which one is your x-intercept and which one is your y-intercept. So in a table, if I see that 0 is in the y position, then I should be able to connect the dots that this is going to be my x-intercept. So the x-intercept occurs when y equals 0, okay? Or in other words, when output equals 0. If that's the table definition for the horizontal intercept, then what should I be saying for vertical? My x value is 0, so 0 paired with some number, okay, that's going to be my y-intercept. So the y-intercept occurs when x equals 0. And it's always the opposite letter, if that makes it easier to remember. And then last but not least, we talk about finding the x and y-intercept. To find the x-intercept, we plug 0 in for y and solve for x. And then to find the y-intercept, we plug 0 in for x and find y. And these all stem from each other, okay? The output is 0, the output is 0. I'm plugging in 0 for the output, okay? Here, the input is 0, the input is 0. I'm plugging 0 in for the input, all right? They are all connected. It's just 3 different lenses in which to look at them. So these are some important features of a graph. Now let's talk about why they're important in terms of a word problem. So we're going to take a look at a particular word problem. It says the formula P equals 300 times 1.028 to the T approximates the population of the United States, where P is the number of people in millions, and keep that in mind because units are important, and T is the number of years after 2006. The first thing, even if you're not physically asked by the problem, okay, the first thing that you should ask yourself is, what is my input in this situation and what is my output in this situation? Think about this, okay? Input is independent. It's going to be something that's going to occur no matter what. So I have population and I have time, okay? Which is going to be independent and which is going to be dependent? Or you can take a look at position clues. The T is inside the function and the P is alone. Okay, so I could just look position at the position and it'll tell me which one is which. What am I plugging in? I'm plugging in values for T, which is years since 2006. And that means I'm measuring, or as a result, I'm getting P, which is the population in millions. The reason that this is so important to state is because you're going to be asked to interpret anything you find with this equation. So when you have to interpret, they're going to ask what it means, okay? So you need to know, what is the input representing? What is the output representing, okay? Now, from previous videos, you should be able to identify that this is a b to the x. This is an exponential. And so I can tell a bunch of different things from this equation. I should be able to pick out the y-intercept. I should be able to pick out the factor and the growth rate, okay? So I just want to make sure that you're always thinking about that when you're presented with any kind of function. What we want to know here is, what is the y-intercept and interpret. So what is the y-intercept, and write a complete sentence to interpret. Interpret means that you have to do it in the situation that's being described. You're not talking abstractly about x-intercept, y-intercept. You're talking about, what does it mean in the problem with units. That's why this is so important, because these are what they represent. These are our units. So first, it's about picking it out. This is an exponential. I can pick it out. The y-intercept is 0, 300. But now it's the interpret part. Or in other words, it's 0 what? 300 what? Can you write a complete sentence to describe what these two numbers mean? 0 means 0 years since 2006. If it's 0 years since 2006, then we must be in 2006. So we're going to say in 2006, the population, because that's what output represents, was 300 million people. Okay, and there's your interpretation. Now, we can find other ordered pairs. We could plug 1 year in. What happens 1 year after 2006, which would be 2007. And we can work this out. And we can write the same kind of sentence to interpret any ordered pair that we know from this formula. Okay? So in the next video, we're going to be talking about, actually, you know what? I'll do one more because I like this one. One more word problem. And then I'll stop the video and I'll get into how to use technology to graph these things. So here's the next scenario. Suppose V equals negative 75m plus 2500, where V is the volume of water in a tank in gallons, m minutes, or after m minutes. Sorry, I forgot a word. After m minutes. Okay. Again, even if the question doesn't ask it, you should ask it. In this situation, what is my input and what is my output? We're talking about volume of water in a tank, and then in gallons, and then after m minutes. Well, which one is going to happen no matter what? Okay, which one is going to be independent of anything else? Time. Time is going to go by independent of anything else. Okay, so most of the time, you're going to see that time is a very common input. So the input here is going to be m, which is minutes, which means the output here is V, which is the volume of water in gallons. So gallons of water, okay? This is important to note because, again, you're going to be interpreting things. This looks like a familiar problem. This looks very much like y equals mx plus b. Okay, this looks like a line, like a linear function. So I should be able to pick out some important information. I should be able to pick out the y-intercept. I should be able to pick out the slope. And because this is a word problem, I should be able to interpret both of those things. So the first question is going to be find the y-intercept and interpret. Finding it shouldn't be an issue, okay? It's supposed to be 0, 2500, because it's always that b value with 0 as an input. Now, it's 0 what and 2500 what. That's why we write this first. After 0 minutes, so after 0 minutes, there were 2500 gallons of water in the tank, okay? Now, after 0 minutes is fine, but you can also say at the beginning. It's another good phrase for that. or you could say initially. It's another good phrase for that. There's a lot of ways to say that you're starting at 0. Okay, so any combination of those things would be good to describe what's happening here. All right. Next, what is the slope and interpret? All right, I'm going to rewrite the problem so this way we don't lose track of it. So the problem was we have V equals negative 75 M plus 2500, and this finds the volume of water V in gallons after M minutes. Second question is find the slope and interpret. Well, we already know that this looks an awful lot like y equals mx plus b. So this number that's in place of my m is negative 75. So that tells me that my slope is negative 75. That part is the more straightforward part. Now we're at the interpret part. It's negative 75 what? Well, remember, fractions are our friends when it comes to slope. I can put that over 1. So it's negative 75 over 1. What does a negative slope mean? A negative slope means that it's decreasing. So what's really happening here? Are we gaining water or are we losing water? Well, if this is negative, we are losing water. We also know that this is the change in output over the change in input, because this is the change in y over the change in x. We talked about rise and run. If this is the change in the y direction, what are the units on the output? The units on output are gallons. What are the units on input? This is why you go back and you state the input and output. Input is minutes. Just by writing that out, I now have almost my entire interpretation. We are losing 75 gallons each minute. Or you can use the word per. It's another nice word that goes along with slope. What's important though? The negative is being described as losing, okay, because you have to describe if it's increasing or decreasing. And then we're describing our output and we're describing our input using this comparative word, either each or for every or per, okay? We could have rephrased this whole thing and said for every minute that goes by, we lose 75 gallons of water. That would also have been the same thing. So there's lots of different ways that you can phrase it. The point is that you're describing the increase or decrease and then the units of change in output per change in input. Last but not least, for this problem, we're going to ask what is the x-intercept and interpret. So we're going to find the x-intercept and interpret. We know that x-intercept is really the horizontal intercept. Okay, so because we don't have x's and y's here, remember. The horizontal intercept occurs when the output is 0. So this means the output equals 0, because I'm looking for the horizontal intercept. If my output equals 0, I know what my output is in this scenario. It's the V. So I want to solve 0 equals negative 75 M plus 2500. Okay? Again, going by the definition, I'm plugging 0 in for the output. And then I have to solve. So take away 2,500. So I have negative 2,500 equals negative 75m. And then divide by negative 75. And then this doesn't come out to be a pretty number. This comes out to be 33.093, which is approximate. I'm rounding this. So that's approximately my M. The point is we have to, oops, nope, that's not right. 33.333. I was looking at the wrong thing. Sorry. Still was approximate. Okay, I'm still rounding this off. But now what does this mean? I have to interpret this. This is the ordered pair 33.333, comma 0. What does this represent? And what does this represent? This is after approximately, because that's what the squiggly is, because I rounded this. After approximately 33.3 minutes, the tank will be empty. Or you could say there'll be 0 gallons left in the tank. That works too. There's lots of different ways that you can say that. The idea of these two word problems is that you always focus on your input and output. Ask yourself, what is my input? What is my output? And when you're doing your interpretation, it always goes back to that. Okay, so always make sure that you're thinking about that. And you have to know how to interpret the important features. All right, so in the next video, I'll show you how to use technology to do some of this. So I'll see you in the next video.